Okay, looking at derivatives and indices. So in this exercise, there is no new learning. All that we're doing, or all that we need to do, is use our knowledge of indices that we learned way back in the start of last term. So essentially, before we derive any functions, so if we have a look at our first function we need to derive, before we derive that function, we need to convert it so that x has an index rather than like a cube root, for instance. So we basically need to get x to the power of something. And then once we have x to the power of something, then we can easily derive. So deriving this is quite hard in its current form. But what I need to do is use my knowledge of indices. So when I'm taking the cube root of x, or let's say I'm taking the square root of x, the square root of x is the same as x to the half, isn't it? And the divided by 2 tells us that that's a square root. So we're looking at the cubed root of x. We're looking at x to the power of a third. So we're not taking just the square root, which is indicated by the 2 on the denominator. We're taking the cubed root. So this function here is the same as, or I'm going to convert it to its index form. So I'm going to have 7x to the third. And now it's in its index form, I can easily find the derivative. So remember, we bring the power down the front and multiply. That's a terrible multiply. And then we subtract 1 from the power. So subtracting 1 you can do with fractions quite easily. So therefore my gradient function, or my derivative, or f dash of x, so this function is going to be 7 times a third x to the, now a third take 1 is going to go to the negative 2/3. And it's okay to have a negative fraction. We just have to remember that we're going to have to swap that out in a second. So 7 times a third is the same as 7 on 3. X to the negative 2/3. And we can simplify this further. It's quite frustrating, but that's okay. So here the negative on our power indicates that it is 1 over. So this will be the same as 7 over 3 multiplied by 1 over x to the 2/3. So remember, a negative in the power means 1 over. I can then, now that I've got 2 fractions I'm multiplying, I multiply the top and multiply the bottom. So let's continue that over here. So I'd have 7 times 1 on top gives me 7. And 3 x to the 2/3. And remembering that this is the same as the cubed root of, so I can convert it back to cube root. So 7 over 3, the cubed root of x squared. So a bit complex there. That's a pretty nasty question, to be honest. So let's have a look at part B. So we want to find the derivative of this function at the point where x equals 2. So first of all, we're going to have to find the gradient function, or we're going to have to derive this function, and then we're going to have to set x equal to 2 in that function. So for part B, y equals 4 over x squared. Remember, we need to convert this so that x is, well, firstly, is not on the bottom of the fraction, and so x has an index. So this is the same as 4x to the negative 2. Remember, the negative lets us bring our x squared back up. Therefore, I'm going to apply my rule. So again, bring the power down, multiply through, and subtract 1 from the power. So we're going to have equals negative 2 times 4 gives negative 8, x to the negative 3. Oops, that's not a very good negative 3. And because I have a negative on my power, I can put it as 1 over. So this is the same as 1 over or I should say negative, no, it's not 1 over, it's negative 8 over, because we had 8 out the front of our x, so negative 8 over x cubed. So this is my derivative function. Now all I have to do is set my derivative function equal, well, we'll find my derivative function when x is 2. So I'm just going to set my 2 into where my x value is. So negative 8 over 2 cubed. Now 2 cubed, 2 times 2 is 4, times 2 is 8. So this is the same as negative 8 on 8, which just equals negative 1. So that tells me at the point where x is 2, the gradient of my function is negative 1. And that's it for this exercise. So just a couple of examples there. So key features here is make sure that you convert your function so that x has either a positive or a negative power, and make sure that x is not on the denominator of a fraction before you try and derive. So it's just manipulating your function so that, yeah, you have a negative power of x and that x is not within the denominator. So good luck with those questions.